Hi and Assalamualaikum everyone. My name is Nur Adriana Najwa and we are from Group K. Today, our friends and I will be giving a presentation about Saturn's wiggle, which is connected to the concept of extraterrestrial quake. So after the conclusion of the presentation, I hope that everyone who was watching can pick up some useful information about Saturn. So this presentation consists of 5 agendas, which are the following: the introduction of Saturn, how the Saturn is wiggle, why and when it wiggle, how we might interpret the wiggles, and finally a conclusion. So how does Saturn form? Saturn formed at the same time as the rest of the solar system about 4.5 billion years ago, when swirling of gas and dust were pulled together by gravity to form this gas giant. There are 2 theories as to how planets in the solar system were created. The first and most widely accepted, co-accretion, works well with the formation of the terrestrial planets, but has problems with giant planets such as Saturn. The second one is the disinstability method, may account for the creation of giant planets. The creation of Saturn is starting with clumps of dust and gas are bound together early in the life of the solar system. And over time, these clumps slowly compact into a giant planet. These planets can form faster than their co-accretion rivals, sometimes in as little as 1,000 years, allowing them to trap the rapidly vanishing lighter gases. Saturn has been where it is now since 4 billion years ago, and it is mainly composed of helium and hydrogen. Saturn is the 6th planet from the Sun and the 2nd largest in the solar system, after Jupiter. It is a gas giant with an average radius of about 9.5 times that of Earth. It has only 1/8 the average density of Earth. However, with its larger volume, Saturn is over 95 times more massive and the volume is greater than 760 Earth. Saturn is the least dense of all the planets and is the only one less dense than water. If there were a bathtub big enough to hold it, Saturn would float. Saturn is located 9.5 astronomical units from the Sun, which is about 1.4 billion kilometers away. So now let's talk about internal of Saturn. The core of Saturn is made up of a core of iron, nickel, and rock, which are silicon and oxygen compound. It also has a deep layer of metallic hydrogen around its core, and the temperature is 11,700 Celsius hot, and the planet gives off 2.5 times as much energy into space as it gets from the Sun. The intermediate layer is made up of liquid hydrogen and liquid helium, while its outer layer are all gas. So as you have heard, most of Saturn is not solid but gases and liquid. But deeper still lies Saturn's core, a dense mass of rock that is roughly the size of the Earth. It is kept solid by continuous heat and pressure. So now let's talk about the concept of Saturn's ring. So do you know that the Saturn's ring are made from the little leftover pieces of what used to be a moon? Yes, actually Saturn has 82 moons in total, and Saturn's gravity on the side of the moon that faces the planet is stronger than the gravity on the side that faces away from the planet. So therefore one day a scientist named Edward Rouchy, who figured out that if a moon gets close enough to a planet, these stretching forces will be so strong that it can break a moon apart. So the theory is there was a small moon of Saturn that got too close to the planet. That small moon got inside Saturn's Rouchy limit, or inside that special distance, and the tidal force broke the moon into pieces. So those pieces spread themselves around the planet, and that is the ring.
Now, let us discuss about the Saturn's atmosphere. In the equatorial region, the wind can reach speeds of up to 500 meters per second at the upper atmosphere. On the other hand, the fastest winds ever recorded on Earth were approximately 110 meters per second. The planet is being pounded by ferocious winds that travels at roughly 5 times the speed of the hurricanes that do the most damage on Earth. The yellow and gold bands that can be seen in the atmosphere are caused by the combination of these extremely fast winds with the heat that rises from the interior of the planet. Due to the fact that the outermost layer of the Saturn's interior is composed of gas, Saturn does not have a genuine surface. To a far greater extent, there are fluids and gases that are moving around deeper within the planet. Interesting information about Saturn. On Saturn, there is absolutely no place for any spacecraft to land or even fly. Any spacecraft that attempted to fly inside the planet would be smashed, melted, and vaporized as a result of the tremendous pressures and temperatures that exist deep within the planet. Hi, I'm Sophia and I will explain about the Saturn wiggles. In the past, astronomers believed Saturn had a rocky core hidden at the center and it's mostly gaseous mass. But new research shows that rather than a solid chunk of rock, Saturn's heart is a slushy and fuzzy mixture of ice, rock, hydrogen, and helium. The constant trembling in Saturn's body causes its rings to wiggle in waves that can be detected as seismic signatures. These seismic signatures will provide us insights that the planet constantly trembling around as if it always wiggles. Using data from NASA's Cassini spacecraft, which recorded the signatures back in 2013, planetary scientists used those measurements to peer inside the gas giant center. From the NASA's Cassini data, scientists calculate and compare structural models with gravity and seismic measurements, and the data can only be explained by a diffuse, stably stratified core envelope transitions region in the Saturn that covers about 60% of the planet's radius and contains roughly 17 Earth masses of ice and rocks. Mankovich, who did the research, emphasized that the hydrogen and helium gas in the planet gradually mix with more and more ice and rock as you move towards the planet's center. They also find out that a Saturn pulsation spectrum is dominated by fundamental modes, F modes, and enriched by internal gravity waves, G modes, imprisoned closer to the planet's center that has been discovered by Cassini stellar occultation studies in the Saturn's C ring. The existence of the G-modes in Saturn suggests that a composition gradient is stabilizing a portion of the interior against convection, since gravity waves are restored by buoyancy. But investigations into Saturn's ring have found waves produced by pulsation modes, providing independent seismic probes into Saturn's interior. Scientists also find out that the gravity mode, G-mode, pulsations that were discovered through the observation show that a region of Saturn's interior is stably stratified by composition gradients, and the G-mode frequencies directly test the planet's buoyancy frequencies.
Hi, my name is Hairia and I'm going to explain why Saturn's rings wiggle. So, first of all, there's oscillation in the interior of Saturn which causes the planet to jiggle. But how is this possible? So, Saturn's core is made up of ice, rocks, hydrogen, and helium, which makes it similar to a slushy. And the oscillation is driven by fluctuations or pulsation modes of Saturn's gravitational field. And as a result, the planet moves about a meter every 1 to 2 hours. And subsequently, Saturn's rings picks up the gravity disturbance and they wiggle around. Next, when does it wiggle? As Mankovich said, Saturn is always quaking, but it's subtle. As Saturn is constantly trembling, the rings picks up the disturbance and wiggles constantly.
What we can do with wiggle? First of all, we can know about the heavy element enrichment, such as large abundance ratio of methane, highest hydrogen, helium, and oxygen. We can trace types of gases and isotopes. The abundance of heavy materials causes the Saturn to oscillate by the magnetic field and tells us about the Saturn formation and evolution. We can also know about the Saturn cloud storms. It's known as Great White Spots by Sanchez La Vega, 1994. It's caused by the large-scale eruption from the rapid growth of clouds and expands zonally until after 2 or 3 months the disturbances fully encircle the planet within its latitude band. It tells about the life cycle of Saturn, includes atmospheric waves, Saturn polar hurricane, and rediscovered North polar hexagon. Wiggles also tells us about the clouds, winds, and the temperature of the Saturn. Zonal jets or zonal wind and temperature will give information about how the wind motions threaten small clouds, sequenced by wind and the gradient of temperature relative to the rotating planets. Zonal jets and the flow around the large oval decay bit high above the tops of clouds indicates the Saturn is decay. The speed of the zonal wind in the upper troposphere and stratosphere of Saturn oscillates with around 15 years period with semi-annual oscillation. Oscillation reveals itself in the temperature on either side of equator that shows similar oscillation occur in the stratosphere of Earth and Jupiter.
Hi, my name is Aidatul Atilah and I will explain furthermore about what can we do with the wiggle. We can study its chromoseismology. The planet's surface moves about a meter every 1 to 2 hours like a slowly rippling lake. Like a seismograph, the rings pick up the gravity disturbances, thus the ring particles will start to wiggle around. This research technique is called chronoseismology, from the Greek word chronos, meaning Saturn, and seismo, meaning quakes. Chronoseismology is how astronomers figured out that a Saturnian day is precisely 10 hours and 33 minutes. By looking at the small waves and tremors of Saturn's rings, astronomers could deduce the movement of the planet's body in a way they couldn't before, which enabled them to calculate its rotation speed and determine the length of its day. Saturn's ring contains multiple spiral patterns that appear to be density waves driven by periodic gravitational perturbations. Using stellar occultation data obtained by the visual and infrared mapping spectrometer on board the Cassini spacecraft, a group of researchers investigated the origin of 6 unidentified searing waves located between 80,900 and 87,200 kilometers from Saturn's center. By measuring differences in the wave's phase among the different occultations, they were able to determine both the number of arms in each spiral pattern and the speeds at which these patterns rotate around the planet. Saturn's ring contains multiple spiral patterns that appear to be density waves driven by periodic gravitational perturbations. Using stellar occultation data obtained by the visual and infrared mapping spectrometer on board the Cassini spacecraft, a group of researchers investigated the origin of 6 unidentified searing waves located between 80,900 and 87,200 kilometers from Saturn's center. By measuring differences in the wave's phase among the different occultations, they were able to determine both the number of arms in each spiral pattern and the speeds at which these patterns rotate around the planet. Saturn rings are used like a giant seismograph to measure oscillations inside the planet. Now, the structure of a gas giant planet can be seismically probed. The detailed analysis of Saturn's rippling rings is a very elegant form of seismology to infer the characteristics of Saturn's core. The researchers say that the observed gravitational ripples indicate that the deep interior of Saturn, while sloshing around as a whole, is composed of stable layers that form after heavier metals sunk to the middle of the planet and stop mixing with lighter materials above them. In order for the planet's gravitational field to be oscillating with these particular frequencies, the interior must be stable, and that's only possible if the fraction of ice and rock gradually increases as you go in toward the planet's center. Their results also indicate that the core of Saturn is 55 times as massive as the entire Earth, with 17 Earth masses of that being ice and rock, and the rest a fluid of hydrogen and helium.
Alright, moving on to the conclusion, I will briefly extract the main points on a few important inputs, which are scenarios for origin of the main rings, evolution of the main rings, and as well as a brief summary of the topic that we covered. As the first scenario suggests that the Saturn's rings are a remnant from Saturn's primordial nebula, this research was specifically done by Estrada and Johnson. So if the rings are said to be the remnants of Saturn's subnebula, then their formation must have taken place in the same exact environment in which the satellites are formed, which must be discussed first, isn't it? Now, it leaves still a big question mark. And moving on to the second one, it suggests that the Saturn's rings are debris from a destroyed satellite. So this was proposed long time ago by Pollack in 1973 and 1975, also together with Harris in 1984. And for the last one, it suggests that they are debris of one or several comets tidally disrupted by Saturn. As for the second one, it is the limited accretion. Here we discuss how a limited form of accretion could take place inside the rings despite the strong tidal forces. In the last 20 years, several analytical studies and numerical models have characterized accretion processes under tidal forces and have shown that an exotic form of accretion may take place in the rings, and they can be further divided into three, which are gravitational instability, tidally modified accretion, and surface taking. Okay, the third point now is collisional cascade. In order for material to recycle back into the rings, a destruction process is needed to occur. Destruction of the biggest bodies or moonlets via meteoroid bombardment could lead to a cascade of smaller collisions. Since the shattering of moon is a random event, ring history will be inaccurate and somewhat unpredictable. And for the last one, which is ring-moon interactions, satellites produces many other dynamical effects on rings. Also, dynamical interactions between rings and satellites can result in a rapid orbital evolution indeed. So, this rapid evolution provides the original argument for the possible use of Saturn's rings. Finally, in conclusion, there are numerous reasons to think that there is ongoing accretion in Saturn's ring. However, its characteristic seems very sensitive to the particle size, shape, and location, and as well as the physics at work. There should be a general trend for bigger bodies as a function of distance from the stimulation. Throughout this whole thing, there are still a lot of unknown, both on the observational and theoretical side. Hence why we concentrate specifically on the ring's basic fundamental characteristics, which are material compositions, mass, and spatial distribution. Actually, only considering these three basic properties is already very challenging. So I believe my teammates and I have discussed plenty enough for everyone to grasp something out of this topic. Hopefully it is beneficial and helpful in many ways for us, today's generation, to always reapply any knowledge, which in turn to making the world a better place. Thank you!